Alright, so in this video we're going to talk about the three properties of logarithms and how they're used to evaluate, expand, and compress logarithmic expressions likewise. Alright, the three basic properties of logarithms are the product property, the quotient property, and the power property. If we have a logarithm with the base b of some product xy, we could expand this logarithm as the sum of two individual logarithms, log base b of x and log base b of y. Add them together. Split it up using the addition sign here. That's the product property. The quotient property, if we have a logarithm with base b of a quotient x divided by y, that's going to be a difference of the log base b of x and the logarithm with a base b of y. And then the power property is a unique one. If we have a logarithm with a base of b of some value x to the pth power, we can bring that value of p, that power, out in front of the logarithm and have p times the log with base b of x. Right, so what we're going to do is we're going to use a couple of these properties to express logarithms in a different form, expand them, compress them, and also evaluate them. Alright, so in this first example here, we're going to evaluate the logarithm with a base 4 of the fifth root of 64. Okay, so to start here, what I recommend is converting this fifth root into a rational exponent. And to do that, we will get the logarithm with a base of 4 of 64 raised to the 1/5 power. That's the conversion from a fifth root of a number to a rational exponent. The next part, notice our base here is 4. So at some point we might want to transform this 64 into something that has the same base, that has a base of 4. Well, it just so happens to be that 64 is 4 to the third, and that is all raised to the 1/5 power. Alright. Now this 4 to the third to the 1/5, 3 to the 1/5, these two powers here, that's the power of a power property. We can multiply the power of 3 and 1/5 to get 3 to the 5th. And now we can use the power of the power property of logarithms to bring this 3/5 out in front of the logarithm, and we'll get 3/5 of a log base 4 of 4. Now over here, this exponent here is really 1 here. Okay? So now the interesting thing happens here. We have a logarithm with base 4 of an exponential expression with the same base. The log and the base go away, and we're left with 3/5 times 1, which is just 3/5. So the value of log base 4 of the fifth root of 64 is just 3/5. Second example here. Let's expand the logarithm, the common logarithm of 12x to the fifth y to the negative 2. It's a common logarithm. We understand it to be a common logarithm because there is no base there. We understand it to be a logarithm with base 10. The very first thing here that I notice is we have three distinct terms here. So we have a product of three completely distinct terms. Now, I don't know about you guys, but I like keeping my exponents positive. So let's rewrite this expression here as a logarithm, the common logarithm of 12x to the fifth over y squared. Okay? I prefer to keep my exponents positive, so when we work with them, we can keep things positive. Okay? Now we have a quotient here. 12x to the fifth divided by y squared. Logarithm of 12x to the fifth divided by y squared. We're going to use the quotient property and take the logarithm of the common logarithm of 12x to the fifth minus the common logarithm of y squared. That's the quotient property. At this point, we now have a product here. So we can expand that as a product justly and get log the common logarithm of 12 plus the common logarithm of x to the fifth, and we are subtracting log of y squared, the common logarithm of y squared. Alright, and then the last thing that we need to do is we need to take care of these powers if we're expanding it completely. Power property of logarithms, the power goes right in front of the logarithm, and we get log of 12 plus 5 log of x minus 2 log of y. You could do it using the product property right away. You could do that, and then you would apply, and then you would get, if you did it the different way, and if you didn't keep your exponents positive, this here would turn into log of 12 plus log of x to the fifth plus log of y to the negative 2. And then when you brought the powers out, you would get log of 12 plus 5 log of x plus negative 2 times log of y plus a negative would get you right to the end result there. Okay? So, but personally, I like keeping my exponents positive. It makes things a little bit easier to work with. One of the final examples here, we have the logarithmic expression 6 times the natural log of x minus 4 plus 3 times the natural log of x, and we're going to condense it. We're going to take it and we're going to write it in terms of one logarithmic expression here. First thing that we're going to do is apply the power property. We have a coefficient here in front of both natural logarithms. So we're going to put it where the power would be if we were expanding this. So we would get the natural log of x minus 4 raised to the 6th power plus the natural log of x cubed. And notice here we have two natural logs here. We have an addition, so that's going to indicate that we're going to use, that's going to tell us that we're going to use the product property of logarithms, and we'll get ln of x minus 4 to the 6th times x cubed. Or if we want to rewrite that, we can rewrite it as ln of x cubed times x minus 4 to the 6th. And you could leave your answer this way. I'm perfectly fine with that. If you want to expand that and do the multiplication, that would take a lot of work, but just know for our purposes I'm perfectly fine with leaving that answer just like that. And then the last example here that we'll do in this video is to condense 4 times log base 3 of x minus 1/3 of log base 3 of x plus 6. So first off, notice we have a coefficient in front of these logarithms here. We will use the power property of logarithms to associate them with these two terms here respectively. So we'll get log base 3 of x to the 4th minus log base 3 of x plus 6 to the 1/3. Now you have an option here if you want to take this 1/3 power and write this as a radical, that's fine. I'm going to do that because it makes life a little bit easier. So we get log base 3 of x to the 4th minus log base 3 of the 3rd root of x plus 6. Now we have two logarithms with the same base. this only works when the logarithms are the same base. If they're not the same base, then you can't use the properties that we talked about earlier. We have the two logarithms with the same base separated by a subtraction sign, so that's going to indicate the quotient property. So we'll rewrite this as the log base 3 of x to the fourth divided by the cubed root of x plus 6 and there's what we have right there's your answer right there. And then since we can't have any radicals in the denominator here, we're going to rationalize this, and by multiplying the numerator and denominator by 2 instances of the cubed root of x plus 6, because that'll give us a get rid of the radical in the denominator. So we'll multiply it by the cubed root of x plus 6 squared and we will get x to the fourth times the cubed root of x plus 6 squared over x plus 6. And there's your answer right there. Okay, so those are the basics of these logarithmic properties. There's 3 of them that you need to know: the product, quotient, and power property. Use them as best you see fit. And that's pretty much it for this video.